Good morning. This is another video by Professor Grenfell in our lecture series for Math 12 Statistics. And today we are continuing in Chapter 9, Section 5. We're going to be going over the p-value method for the f-test. And ultimately we're going to be covering example 9-16 as a result, or as an example of this. Okay, so let us just go ahead and take on a hypothetical example. This is not one of the specific ones from the book, but we'll have it as a simple task. We'll compute the p-value for an f-test where f is equal to 2.57. The degrees of freedom for the numerator, dfn, are 5, and the degrees of freedom for the denominator, dfd, are 3. And now you may recall when we were using one of the z-tests, either for a population mean when we knew the population standard deviation, or perhaps for a proportion, we could simply just go ahead and take that z value and plug it right into table E and look up the exact area underneath the curve. In the case where we use the t-distribution or the chi-squared distribution, when we're using one of those tests, either the t-test or the chi-squared test, you might recall there, we only have certain values of alpha that correspond to some very nice and precise and exact values of p. I'm sorry, I said that exactly wrong. We only have certain values of alpha, and those t values or chi-squared values, or in this case, the f values, are the critical values. We don't have the full range of all possible f values to plug in into this distribution table in order to get the area underneath the curve. We only have it for limited, these pre-packaged values for alpha. And so what we have to do, the procedure for what we have to do, does not give us the precise p-value. It gives us a range for the p-value. And we'll go through that procedure for finding the p-value with the f distribution. So a helpful way to find the p-value when we're performing an f-test is to create a little table like this. So across the top row here, I have got alpha and the various pre-packaged values that I was kind of alluding to. So the standard ones are 0.10, 0.05, 0.025, 0.01, and 0.005, corresponding to the most common critical f values that we will be finding. So keep in mind, if we are using the t-distribution or the chi-squared distribution, the way that table F for the t-distribution, table G for the chi-squared distribution, the way that these tables are organized is already in this format. We have the various different values, the distinct values for alpha going across the top, and then in one row, for instance, of table F, let's say, the T table, all of these values are already filled in for us if we were using the T table. Same thing, similar sort of thing if we're using the chi-squared table. We already have all of these values filled in. Those are just the values that are in that whole row corresponding to the correct degrees of freedom for our T distribution or for our chi-squared distribution. Now, what do we have to do for the F? we have to do a little something different, because table H is got a page instead of a column for each value of alpha. It's got a whole page. And then within that whole page, we have two values that we have to feed in, the degrees of freedom for the denominator and the degrees of freedom for the numerator. And so that is what we'll do. I'll go ahead and I will start, let's see, I'm going to go ahead and start on page 787. And I am starting on page 787 because that is the page on table H for the F distribution. That corresponds to alpha equals 0.10. And on each of these pages that we are going to be referencing, we're going to be looking in row 3 and column 5. So remember, we have 3 degrees of freedom for the denominator, and those are, in that first column, we'll go down to the third row there, corresponding to the 3 for degrees of freedom for the numerator. I'm sorry, the denominator. And then second of all, we have 5 degrees of freedom, so that's why we're moving over to column 5. And so the value that we see there on page 787 is 5.31. And so we will go ahead and record 5.31 for the critical F value corresponding to alpha equals 0.10. Then on page 786, so the pages are going backward here as the values of alpha are decreasing, we're going to be looking on page 786 in the same location, row 3, column 5, and we see the value 9.01. And we'll continue on in the same style, the same manner. We'll look on page 785, okay, because that is the one for alpha equals 0.025. And we see in row 3, column 5, same place we look every single time, we see the value 14.88. And again, 784, same location, row 3, column 5, you get 28.24. And then last, in the same sort of manner, 49.39 is F subscript alpha, for alpha equals 0.005. And that is found on page 783, same location, row 3, column 5. And now, again, to remind us, if we were using our t distribution or our chi-squared distribution, one of these ones over here, we would already have all of this same exact similar sort of information, all of the critical values already all in one row for us. So essentially here, we are just basically taking this enormous table and condensing it down so that we have one convenient row that we can look at. Then what we did is we took whichever statistic we were talking about, the t distribution or the chi-squared distribution, we would be looking for our particular test statistic and what range it fell in. So we would say, where is this F value? If it is in between any of these critical F values, then the corresponding p-value would be, let me see, well, since I drew this arrow here, then the p-value would be in this range here. So basically, we're going to kind of play this same game. We're going to see where is F in relation to these critical F values, and then that will give us not the precise area underneath this curve for our particular test statistic. However, it will give us a range for which these values are in between. Okay, and if you just scroll back up here, we have 2.57, and notice 2.57, f equals 2.57 is not actually in between any of these values. Let me scribble that out. Where is it? Well, I'll still use red because it's a little bit confusing. It's not in between any of them. It is below 5.31, which is the lowest of these critical F values. So here it is off the charts this way. What are the alpha values doing as we proceed in this direction? Notice they are increasing. So since the p-value is less than 2.57, no, wait a minute. Oh, okay, hang on. I made a whole bunch of bungling errors. I said since f is less than 2.57, the p-value is greater than 0.10. I meant to say this value, 5.31. Okay. F is equal to 2.57, so it doesn't make sense that it's less than 2.57. That I said the wrong thing. So since f is less than 5.31, which is the value on the extreme left side of the table, then the p-value is greater than 0.10 because that is the value on the extreme left of the table. Our p-value is on this side of the table, so that would be greater than 0.10. And remember, whenever your p-value is large, then that means that is a very common occurrence, and you will not reject the null hypothesis if your p-value is greater than whatever alpha was. Since alpha is usually never bigger than 0.10, our p-value is going to be greater than any alpha. So here, no matter what significance level, the p-value is coming back so large that there's nothing significant about this test. And so in all of these cases, we will not be rejecting the null hypothesis because of our p-value. And actually, I'm going to stop this video so it's not excessively long and pick up example 9-16 in a separate video. All right, until then, good day.